Hey guys, so let me begin by explaining exactly what we're doing. What we are performing right now is a process called concrete crack stitching. And in this particular case, there are many ways that you can stitch concrete back together, whether you're using a bonding concrete mortar, or if it's aggressive, you chip it out first. But what we're doing is we're just stabilizing cracks that don't seem to be getting worse. There's no unlevelness, but we don't want the cracks to show through the overlay. So what we are doing is performing a polyurea filling stitch. Now, in Florida, most driveways are poured using a wire mesh. It looks like a fence, and that's what they use to reinforce the driveway. They either use that or fiberglass fibers inside the concrete without the mesh at all in most cases. So anything over, 4 millimeter is really overkill to stitch concrete back together. Now they make other crack stitching devices and things, but we find that those are overpriced, and we have to overprice our customers to do something that we think ours is just as good. So at this location, we're putting 4 millimeter basalt rebar into these slots that we're cutting, and then we're going to bond it to the concrete and bond the crack with a polyurea joint filler. And some epoxy guys will use this in garage floors for cracks. It's a very low viscosity and designed to penetrate into the crack and solidify and bond the concrete back together. So a little about basalt. We like to use basalt. It's light. We can carry it on board without much weight. It's tensily stronger than steel. It's non-conductive. It expands at the same rate as concrete. So we feel we get all the benefits without any of the downfalls with steel. And as far as the systems go, with the stitches that you can buy commercially with the epoxy, we pretty much have the exact polyurea fillers that they use, only we buy it in bulk. So it's a win-win without having to pay all those high rates, and we don't have to pass that on to you guys. All right, so those are all of the basalt rebars that we have. They're 4 millimeter, and we carry different gauges of them. I mean, they come in, regular rebar sizes, number 3, number 4, number 2. Now, these are real thin, but they're still stronger than what that wire mesh, if it's even in there, would be. And if you go too strong, what you'll create are, it's hard to explain, but you can create islands of stability, and then the concrete that doesn't have the rebar in it cracks away from where you stabilized. So, you don't want to overdo it. And this is me pouring the polyurea in, and as I push those rebars in there, I'm filling that crack all the way to the top. And this polyurea is designed to harden very quickly, and also designed to penetrate deeply into the concrete pores and the crack. After profiling, which you'll see, the overlay should do the rest of the work for us.
I think I like it.
Now, back to stitching. Stitching has been around for a long time. They've tested this out on high traffic roads that have cracks in them, and have been successful in solving the issue. Depending on the severity, we would change tactics. Like This tactic here with just the cutting the slots in the 4mm, that's really designed to just stabilize a crack that's there that's not structural. But if they were structural cracks, we might have to go more in depth, like chip the crack out or cut slots for thicker gauge rebar and use a bonding concrete mortar.
I think I like it.
So this is us profiling it down any of the high spots, so it's less noticeable after we put the overlay on. And we'll re-clean the surface after the profiling is complete. Now we like using the polyurea because there's no cure time. But that's pretty much it. Thanks, guys.